Welcome to the class, dear students. Yes, today we have come to the exact differential equations. In the previous lectures, we have done the variable separable, the homogeneous, the non-homogeneous differential equations, and then the linear and the Bernoulli's equations, how to make the non-linear differential equations transform into linear differential equations and solve it. Now, in today's lecture, I am going to do the exact differential equations. How to solve this type of exact differential equations. First of all, I'll write down the standard form of the exact differential equations, that is given by m of x comma y dx plus n of x comma y dy is equal to 0. This is what the standard form of the exact differential equation. When we say that it is exact, if and only if dou m by dou y, that is the partial derivative of the function m with respect to y, we have to differentiate this, and then it should be equal to the partial derivative of the function n with respect to x. This will be an exact differential equation if it satisfies this condition. This is the important condition to show that, to verify that whether it is exact or not. Once the equation has become an exact differential equation, then how to find out the solution, the steps to solve, steps to find out the solution. What is this first? What we do is, of course, we find out what is dou m by dou y and dou n by dou x and verify whether the given equation is exact or not. First verify whether the differential equation is exact or not. Once that is done, then simply we'll write down the general solution. The general solution of such a exact differential equation is given by integral of m of x comma y dx. Now we are integrating with respect to x by treating y as a constant plus n of y dy. It is, remember, this is not n of x comma y, this is n of y. So what we do, we just leave the terms consisting of x. Leave the terms containing x. Only the terms containing y we need. We take those terms now. That means the function should be independent of x. Okay, these two terms is equal to, and this is equal to c. This is what the solution for the exact differential equation. Now let us solve the problem so that you will understand how to solve this type of exact differential equations. X square minus 2xy plus 3y square dx plus y square plus 6xy minus x square dy is equal to 0. So this is what the equation. Now how to find out what is m of x comma y? Here m of x comma y is what? X square minus 2xy plus 3y square. And what is n of x comma y? It is y square plus 6xy minus x square. This is what n of x comma y. So now what we do is, we just differentiate this. Partial derivative we find out with respect to y. So now what is the partial derivative of y means what? We have to differentiate this with respect to y. So we treat x as the constant. So remember that we treat x as the constant. So it is x square minus 2xy. So now what is the derivative of x square? 0. Now in the terms 2xy, what is the constant? 2 is a constant, x is also a constant because you are differentiating with respect to y. So it is minus 2x times of derivative of y is 1 plus 3y square derivative becomes 6y. Okay, and then we differentiate n with respect to x. Now here when we differentiate with respect to x, y is a constant. So y square derivative becomes 0. So we write this as 0 plus, here the constant is 6 is a constant, y is also a constant. So x derivative is 1 minus x square derivative is minus 2x. Now observe dou m by dou y and dou n by dou x. Both of them are the same, right? So therefore dou m by dou y is equal to dou n by dou x. Therefore, it implies that the given equation 1, let us call this as equation 1, is exact. First, we have to verify whether it is exact or not. Once it is exact, then the general solution is given by integral of m of x comma y dx plus n of y dy. So here what I told, leave the terms containing x terms wherever you get. So you have to remove those x terms, only the y terms you should consider. So now in m of x comma, what is the function here? That is integral of is equal to c. Okay, x square minus 2xy plus 3y square dx plus n of y. That means here you observe the term n is y square is, there is no x in this term. There is x in this term. There is x in this term. So we have to leave these two terms. We are considering only this term which consists of y square. Clear? So what we do now? It is just y square dy is equal to c. Let us now solve this integral. Integral of x square is x cube over 3 minus, what is the constant? 2 comes outside. Y also comes outside. Integral of x is x square by 2. I hope you are able to understand this step. So we are integrating this 2xy. Okay. When you are integrating 2xy, we generally take the constant outside, right? So 2 comes outside, y also comes outside because we are integrating with respect to x, treating y as a constant. So minus 2y. Now remaining is x, so x square by 2. Now the whole 3y square comes out. So integral dx becomes x. So now that is 3y square outside. Integral of dx is x. Now integral of y square is y cube over 3 is equal to c. So how can you rewrite this as? This 2 gets cancelled. This is x cube over 3 plus 3xy square minus x square y plus y cube by 3 is equal to c. This is what the solution of the given equation. Is that clear, all of you? So that is what the method to solve an exact differential equation. Okay. Now let us go to do the next problem. Now this is integral of 2xy cube plus y cosine x dx plus integral of 3x square y square plus sin x dy is equal to 0. This is what the equation. So here again we find out what is m first. What is m of x comma y is the dx component, which is 2xy cube plus y cosine x, and what is n of x comma y is 3x square y square plus sin x. Now we find out what is dou m by dou y. So with respect to y you are differentiating, so 2x is a constant, derivative of y is 3y square plus derivative of y cosine x. Cosine x is a constant, derivative of y is 1. Next, dou n by dou x. Now the constant is 3y square, Derivative of x square is 2x. Derivative of sin x is cosine x. Now observe now, it is 6xy square. It is 6xy square plus cosine x plus cosine x. So therefore what you can say, dou m by dou y is equal to dou n by dou x. So it implies that, let us call this equation as 1. Therefore 1 is exact. So the verification is over. Once the verification is over, we can write down the general solution. What is the general solution? Integral of m is what? 2xy cube plus y cosine x dx over x plus. Now observe what are the terms which are not consisting of x. In this I have x, in this I have x. So I am not considering any term from n of y. So it is just 0 dy is equal to c. I hope it's clear. So now we are going to integrate this. Now what are the constants here? Whenever we are integrating, we take out the constant. 2 is a constant, y cube is a constant. So we take out 2y cube and x integral x square over 2. Again y is a constant. Integral of cosine x is sin x is equal to c. This becomes 0 anyhow. This 2 gets cancelled. So we'll remain with x square y cube plus y sin x is equal to c. So this is the general solution of the equation. I hope you could follow it. So simple equation, so simple the problems are. So you can get good score if the exact differential equations are given to us. So now coming to the next problem. Integral of secant square x tan y dx plus, I'm sorry, not integral, it is secant square x tan y dx plus secant square y tan x dy is equal to 0. This is what the differential equation. Here also I wrote it as integral. I'm sorry, dear students. So the equation is only this one, right? So it is 2xy cube. It is 2xy cube. This is 3xy square dy. That's it. I didn't write. Okay. So the third equation is this. So now here again, what is m? M is secant square x tan y and n is secant square y tan x. So let us find out what is dou m by dou y, which is the constant here. Total secant square x is a constant. And what is the derivative of tan y? It is secant square y. Next, what is dou n by dou x? Now the constant is secant square y. Derivative of tan x is secant square x. Now both of them are equal, correct? So therefore we can say that dou m by dou y is equal to dou n by dou x, and it implies that equation equation 1 is exact. So verification is over. Now the general solution. So the general solution is integral of m is what? Secant square x tan y dx over x plus. What are the terms which are not consisting of x in n? Nothing, no? Therefore it is 0 dy is equal to c. So now the constant here is what? Tan y we will take out. Integral of secant square x is tan x plus c or is equal to c. So tan y tan x is equal to c is the solution. That's it. So simple they are for the scoring purpose. So please concentrate and practice properly to solve this type of the exact differential equations. Now coming to the fourth question, it is integral of y sin 2x dx minus of y square plus cosine square x dy is equal to 0. So now what is m here? It is y sine 2x. And what is n here? Please remember there is a negative sign here. So along with the negative sign we have to take. If it's positive it's okay. If it is negative you have to be little more alert. Now what is dou m by dou y? The constant is sine 2x. Derivative of y is 1. And what is dou n by dou x? Now the constant is y square, derivative is 0. Now minus cosine square, that means minus 2 times of cosine x. Now chain rule, cosine x derivative is minus sine x. So now 2 cosine x sine x, which is given by sine 2x. There is a formula that sine 2x is equal to 2 sine x cosine x. This is the formula. So accordingly we get this one now. So now this is what? Therefore it is equal to sine 2x. Therefore dou m by dou y is equal to dou n by dou x. So implies that equation 1 is exact. Call this equation as 1 is exact. So verification is over. Now we write the general solution. So the general solution is what now? Is integral of y sine 2x dx. Now what are the terms which are not consisting of x? Only y square is there. So minus of integral y square dy is equal to c. So now take out y outside. Integral sign is minus cosine 2x over 2 minus integral y square is y cube by 3 is equal to c. You can take both of them are having minus, right? So you can write y cosine 2x over 2 plus y cube by 3 is equal to negative of the constant is again a constant. So you can write like this. This is the general solution. Yes, okay. Let us now go to do the last problem. This is number 4. Let us have the two more problems we will do. Fifth problem is integral of, y times of 1 plus 1 over x plus cosine y dx plus x plus ln x minus x sin y dy is equal to 0. So what is m here? It is y times of 1 plus 1 over x plus cosine y, and n is x plus ln x minus x times of sin y. Now call this equation as 1. Now what is dou m by dou y? With respect to y you are doing, so 1 plus 1 by x is a constant, derivative of y is 1. Now derivative of cosine y is minus sin y over. Now what is dou n by dou x? Is derivative of x is 1, derivative of ln x is 1 over x, derivative of x sin y, constant is sin y. So it is this one. So you can observe both of them 1 plus 1 by x plus minus sin y, both of them are equal. So therefore dou m by dou y is equal to dou n by dou x. So it implies that equation 1 is exact. Okay, that is over. Now we have to get the general solution. What is the general solution? Integral of, the general solution is integral of y times of 1 plus 1 over x plus cosine y dx. Now what are the terms which are not consisting of x? There is x, there is x, and there is x. So we are not supposed to take any term from n. So it is 0 dy is equal to c. So now let us solve this integral. Y is a constant, so take it out. 1 dx is x, 1 by x is ln x. This integral over plus cos y is a constant outside, integral dx is x is equal to c. So the solution is what now? xy plus y ln x plus x cosine y is equal to c. This is the general solution. I hope it's clear. So simple, these problems are, if you practice then only you will get these problems very easily. Now 2xy e raised to xy square minus 3y square dy plus y square e raised to xy square plus 4x cube dx. So what is the equation here? What is m here? So if you write m as 2xy e raised to xy square minus 3y square, then this is wrong. Why? Because the equation, in the equation always remember dx component is m, dy term is n. So if you do like this, you will get the total mistake. Totally your answer will be, you will not be getting any marks for that. Okay, so please remember that. So what is m here? M is y square e raised to xy square plus 4x cube, and n is 2xy e raised to xy square minus 3y square. Okay, now let us find out what is dou m by dou y with respect to y. So y square, e power xy square into y square. Now observe here, I will write once again the equation m. Why? Because m is y square into e raised to xy square multiplied by e raised to 4x cube. You can, because there is power is added, so we can multiply. So similarly n is equal to, there is no change here, we will write like that only, 2xy e raised to xy square minus 3y square. Okay, let us find out what is dou m by dou y. Now here it is y square into the total constant term is what here, in the place of this is what the constant term. So first we take it out, e raised to 4x cube times of dou by dou y of y square e raised to xy square. In the previous terms there is no two terms. Here we have two terms which are consisting of y. Therefore we have to do little carefully the differentiation. Now here also, to find out dou n by dou x, now the constant is what? 2x. So we differentiate this with respect to, the constant is what? Dy, y, 2y. So we write it as 2y outside, and we write dou by dou x of x times of e power xy square, and now 3y square derivative is of course 0. So that's it. So now what it is? It gives you e raised to 4x cube into, now since dou by dou y of, there are two terms, what we use? We use the product rule, y square into derivative of this plus e power xy square into derivative of y square, because we have to use the product rule here. So it is y square multiplied by e raised to xy square derivative is e raised to xy square. Now the chain rule, xy square derivative with respect to y, so x into 2y. So this is what the first term, plus e raised to xy square into derivative of y square is 2y. So this is what your dou m by dou y, which is given by, you can rewrite this, e raised to 4x cube, and both of the terms are having e raised to xy square times of 2xy square into y is y cube plus 2y. So this is what your dou m by dou y. And let us see what is dou n by dou x. What is it? 2y times of dou by dou x of this again. In this again you have x into both the terms, so you have to use the product rule. So what is that? X times of e raised to xy square into derivative of xy square with respect to x, which is y square, plus e raised to xy square into derivative of x is 1 over. Understood? So what is this giving us? It is e raised to xy square, and here your n is also y square xy cube plus 4x cube. So it is, I forgot, I didn't write this y square. N is 2xy e raised to xy square minus 3y square.